Okay, so in this video, we're going to take a look at the second chapter of the Python for Mathematics book. And so what we're going to do here is use Python to handle symbolic mathematics, okay? So when we start mathematics in primary school and early years of high school, we're mainly dealing with numbers, all right? And really what we're doing there is not really mathematics, it's often arithmetic, okay? All of a sudden, there are letters that start appearing. And basically, we're going to jump straight to that stage where we use Python to handle these letters and symbols, okay? So, here we go. So we're going to solve this particular problem. There's essentially two separate problems. They're not really related either. First is to rationalize the denominator of square root of 2 plus 1. And then a problem related to this quadratic. And in that quadratic, we want to find the discriminant of the equation, make a conclusion about the graph of the function, and then finally complete a square. All right? So what we're going to do is navigate to our folder with our notebooks in it, and I'm going to go ahead and create a new notebook, and I'm going to call this algebra. Okay? And the very first line of this tutorial tells us to import SymPy. And what this is doing, and again, don't worry too much about understanding what we're doing at the moment, that comes later. But what this is doing is essentially telling Python we're going to use another toolbox. So if you think of, if you're a carpenter, and I'm really not the DIY person in my household, but if you were a carpenter, I imagine you have one main toolbox, and then for some particular pieces of work, you might go and get a special toolbox. And this is the same thing. And this particular toolbox, SymPy, where the SYM at the start stands for symbols, and symbolic is where we're going to have these tools to do all our symbolic mathematics, okay? And so the first part of the question just tells us to calculate, well, sorry, to essentially simplify 1 over the square root of 2 plus 1. And so what we're going to do is we're going to say, all right, our expression, and so here we're creating a variable called expression, and now we're going to give it a value, all right? And that is 1 divided by, and then we'll open some brackets, and the square root of 2, we're going to specifically use the square root tool, SQRT, from the SymPy toolbox, okay? And so you write the name of the toolbox, a dot, and then SQRT. And then square root of 2 plus 1. And if we take a look at expression, what's quite nice here is that it is being very exact. It is keeping our actual symbols aligned. If we swapped out and used a different library, so there's another library called math, and if we did 1 divided by math dot square root of 2 plus 1, that gets rid of the symbol, right? Square root of 2 is this symbol, and it essentially approximates the number. It approximates it to a lot of digits, but it's still just an approximation. As mathematicians, we're more interested in the exact value, these symbolic values, which in this case are 1 over 1 plus square root of 2. All right? Now, here I just calculated it and threw it away, essentially. Here I saved it to, I assigned it to this variable called expression. So I can always just come back to expression and see it. One of the nice things about using Jupyter is that the mathematics is automatically rendered in a way that looks nice. And this actually uses LaTeX underneath. Now, what we want to do is, so one thing worth noting is that if we want to get the numeric value, if we need to, we just use this float tool here. So float, open brackets, and what we want. And float is a computer scientific term for a digit that's imprecise. And by imprecise, we mean not exact. It's incredibly precise, but it's just not quite exact. And in fact, in these particular two cases, we see that we start seeing a difference right at the end of these digits. An insignificant difference, but still. So float is a way of taking a symbolic exact expression and getting it a numeric value. But what we want to do is simplify this. And so we use our SymPy toolbox, and we use a tool called simplify. And if we do the expression, we just get root 2 minus 1. And if we're not too sure where that comes from, it's good to use our mathematical knowledge and confirm this. And this is where using a tool like Python just allows us to do our mathematics more efficiently and verify them. But it's always worth making sure we know what's going on. So if I jump over to a whiteboard, or indeed a blackboard in this case, what we had is that we had 1 over square root of 2 plus 1. And if we multiply both the top and the bottom by 1 minus square root of 2, in other words, multiply it by 1, we get 1 over square root of 2 plus 1. This is just a minus b times a plus b. And so what we have is 1 over a squared minus b squared. So 1 squared minus 2. Sorry, this should be 1 minus root 2. It's root 2 squared, which is just root 2 minus 1, because this here is minus 1. So that's all that's happening here. And SymPy is just directly jumping to that for us. Now, that was the first part of the question. The next part, if we go back to it, is all about this particular quadratic, 2x squared plus x plus 1. Okay? And so what we're going to start doing is, first of all, writing down this expression. Now the tricky thing is we want this 2 times x squared plus, I've already forgotten what it was, 2x squared plus x plus 1 plus x plus 1. And if I run that, it says I don't know what x is. Python at this point can't use x as a symbol. Hey, puppy. My dog just came in to say hi. Good boy. But this is where SymPy becomes powerful, because we can say SymPy, sorry, x is actually the SymPy, oops, I can't spell symbol, x. And now if we run that, it's like, oh, okay, I now understand. And indeed, x, if I say, what is x minus x? It knows that's 0. X minus 2 times x, it knows that's minus x. I'm just going to delete this cell. And so now we have this, and we can say, all right, let's save this as our expression. So I'm overriding the previous expression variable. And now if I look at expression, I get this. And the first part of the question asked us to find the discriminant of expression. And for those of you who might need a slight reminder, if we have a quadratic a squared, sorry, maybe I need a slight reminder, ax squared plus bx plus c, the discriminant of that is b squared minus 4ac. So in our particular case, we got 2x squared plus x plus 1. Let me just convince myself that I'm remembering it correctly. 2x squared plus x plus 1. And so the discriminant that we're expecting, often denoted by that big delta, is going to be 1 minus 4 times 2 times 1 is going to be minus 7. Okay? Well, that's all doing it by hand, and we can indeed just use Python to do it. And if we do sympy.disk, and there I pressed tab. So I typed those first 4 letters, and I pressed tab. And that's a really powerful use of Jupyter, is essentially removing the human error. And so you'll see me from now on, whenever I'm typing, I'm going to be pressing tab all the time to let the computer guess what I'm doing. And indeed, I want the discriminant. That's the command I want. And if I say, get me the discriminant of my expression, again, I use tab there. If I press enter, it tells me it's minus 7. So if it's minus 7, what does that mean? Well, that just means that there are no real roots, which means that, and if I go back here, which means that our quadratic is either going to be like this or like this. And in particular, because we got 2x squared plus x plus 1, the sign of the leading coefficient is what matters, which means we've actually got this one. All right? We can just confirm that, and if we do, to do that, we create an equation, which, hi son, my son's just come in. Oh. Yeah, I'm solving some equations.
Yes.
Yeah. I'm recording this for my students. How was your walk?
Okay.
Yeah?
Okay.
Was it nice? Okay. How was the... Yeah, should we say bye? Okay, sorry for that interruption. So we create an equation, and the equation is something that has a left-hand side, so our expression, and the right-hand side, which is 0. And this is the difference between an expression and an equation. An equation, there's an equal sign that is equating two things. And so if we take a look at that equation, and here I'm just following along with the steps here, okay? And what we can do now is solve that equation. And we do that using the solve set tool inside the SymPy toolbox. And we pass it an equation, and then we can omit it, but in some equations you'll have multiple variables, so we should always say what variable we're solving for. Which is just x in this case. And indeed, if we solve that equation, we see that the roots are all imaginary, and so our graph will just be that convex parabola above the y equals 0 line. And so that's, if I just go back to the question here, that's just this question. What does this tell us about the graph? Okay? So then the next part of the question is completing the square showed the minimum point of f of x is that. And so what we need to do here is start out by understanding what we mean by completing the square, all right? And a square will be written in this system. So if we go back to the blackboard, and we got x squared plus 2x squared plus x plus 1. Completing the square means writing that out as a times x minus b squared plus c. All right? And so really what we want to do is we want to solve this equation. And what we're going to do mathematically is just take our equation and expand this. So we're going to have ax squared plus some other stuff. And we're going to let SymPy do that. And then know that our coefficients have to match up on either side. So we're going to go ahead and do that now. And so the first thing we're going to do is create a new expression, completed square. That's just following down these steps here, which is going to be ax minus b squared plus c. Oops. Now if I just run it like that, there's an error that comes up, because again, it's saying the name error, I don't know what A is. And that's because we're missing this extra step at the start, which is the same one we did with X, which is to say A is a symbol, B is a symbol, and C is a symbol. And now if I run that, it's like, yep, no problem. And let me just take a look at our completed square. It's saying, okay, that's what it is. Okay. If you note, I'm doing something slightly differently to how it's done in the tutorial, is that I've put them all on 3 separate lines, one after the other. Whereas you can do them in one go, where you just separate them by a comma. And this is a neat particularity of Python. It does exist in other languages as well, but it's just this allowing to assign things in that particular way. So the first thing we're going to do is just expand this completed square. And we do that using SymPy.expand. And we just get this ab squared minus 2abx plus ax squared plus c. Recalling what our expression was, it's 2x squared plus x plus 1. And so we immediately have an equation for a. We know that ax squared is 2x squared, so a is equal to 2. In the tutorial, I write down that equation. I use solve set to solve it. We're not going to do that here. We're just going to directly substitute, into our completed square. We're going to substitute this value for a. So we're going to say we want a to be 2. Note, I use curly brackets. We'll see in a later chapter of the book what those curly brackets represent. But for now, we just know that we need to put our curly brackets inside this subs, short for subs, and then a colon as well. And if I run that, it is just put what was A is replaced with 2. I'm actually going to overwrite the variable. So I'm going to say completed square, which still at this stage has an A. I want you to be what was completed square, replacing the A with a 2. Oops, completed. And so there, completed square is now this. If I now expand completed square and compare it to my expression, if I now look at the equation for x, I see that minus 4b has to be 1. I'm going to go through the steps of writing down that equation. So the equation is simpi.aq. The left-hand side I'm going to say is minus 4 times b, and the right-hand side is 1. Note I'm not using LHS for left-hand side and right-hand side because I don't need to, and it's fairly obvious what I'm doing. And so my equation is indeed minus 4b equals 1. And we'll solve that equation. And here, we don't really need to. We know exactly what b is, but here is one of those points where it would be very easy to make a mistake, very easy to make a sign mistake, for example. And now I want to solve that equation for b, and I get that b is indeed minus 1 over 4. And so what I'm going to do here is the exact same thing as before, but I'm going to substitute this value for b. And so I'm going to say it's minus 1 divided by 4. But before I run that, I want us to think about this a little bit. If I were to do this, it wouldn't pass in the symbol of 1 over 4. It would calculate 1 over 4, get that that's 0.25, and I'd be carrying around that 0.25 everywhere. And we want to avoid doing that. We want to stay exact as much as possible. And so I just use simpi.s for symbol to just say, this number 1, I don't want you to consider the Python 1. I want you to transform that to a simpi symbol. And I only need to do one of these two things. I could either do the 1 or the 4, and it knows when it's then operated with another one to stay within these symbols. So if I do that, that is now my expression. And then just as before, we're going to expand that. And let's just write down our expression again. And if we remember that, we see that we've only got one thing left, which is to get this 1, which is c plus 1/8. So I'm going to create a new equation. And the left-hand side is going to be the symbol c plus, here I have to do the same thing with simpi.s1 divided by 8. And the right-hand side is just 1. And if I solve that, solve that equation for c, I get that c is 7/8. And so now I'm going to, again, substitute that in. Completed square equals completed square dot subs, but what I want to substitute in is the value for c, which is now going to be 7/8. And there we go. That is our completed square. And now, if we go back to our tutorial, the question asked, use this to show that the minimum point of f of x is minus 1/4 7/8. And what we've got is, if I remember my final expression, so it's 2 times x plus 1/4 squared plus 7/8. Some of you, it might already be apparent what's going on here, but what we have is that everything, all these terms here are non-negative, and so the way to make this as small as possible, remember we're asking for a minimum, is to make the only term we can as small as possible, which is this one, and the smallest that will be is when x is equal to minus 1/4, because that makes this 0, at which point the minimum value is 7/8, which is what the question suggested. Okay, and we can indeed just confirm that if we do completed square dot subs x minus simpi.s1 divided by 4, we indeed get 7/8. Okay, and that's the basic idea of what we've seen here. Throughout this tutorial, we have seen how to create symbolic expressions. If they're numeric ones, how to convert and obtain the approximate values using that float command. Purely symbolic ones, where there are no numeric symbolic ones, but just letters, how to expand and simplify them, how to create equations, how to solve equations, and how to substitute expressions substitute values back into expressions. All right? And this is all there in the how-to section as well. So how to create a numerical value, how to get the numerical value of a symbolic expression, how to create a symbolic numeric value, how to factor an expression. That we didn't do in the tutorial, but we saw how to expand it. The factorizing expression is just as simple. How to simplify it. And we do recommend you read the simplify part of this chapter. How to solve an equation using that solve set expression, and then how to substitute a value into an expression. So again, I recommend going through the tutorial, maybe watching the video and working with me as you do it. Don't worry too much. If you have a couple of questions that come up, that's good. Then read through the how-to section. This is the point I'd recommend you make your own notes. Then move on to the exercises. As before, I say, do spend some time struggling with that a little bit. Something's broken there. I'm going to fix that. The website's not quite right. There's not 12 questions. These are actually just questions inside a question. When you're ready to work through the exercises, do struggle with that a little bit, right? Be uncomfortable. Being a mathematician is all about being uncomfortable. And then work through the solutions if you need to. And finally, if you want, there's some further information that you're welcome to read up, and I encourage you to, but it's certainly not going to be assessed. Right, I hope that was okay. If you have any questions, do get in touch. And yeah, this is kind of the first step of really using Python to solve problems for us. And you're not just required to use these tools within this course. I'd encourage you to use them in other courses. And the idea is not to replace you as a mathematician, but to help you be